So here, this is the operations of a linear data structure. So in the non-primitive data structure, we have one of the category, one of the type of the non-primitive data structure is that arrays. Okay, so that arrays, why we need arrays, what is that all we are going to be studying now. Okay, so in your first POC, you people have studied what is variable. Is it not? Variable is nothing but it is a storage where we are going to store some value. It is a storage location, or a variable is a name of a storage location where we are going to store some data value. For example, if I will write int a, it indicates that a is a variable of type integer. So where in this integer variable we are going to store some integer value. Here in memory location, 2 bytes will be allocated for a, and in that 2 bytes we will going to store our value. So that is a variable. So in our programs, you people have done so many programs, okay, using the variables. So even using the array also you people have done. So but in brief we are going to study here. Okay. So here in variable, how many values we can store? Only a single value. Is it not? Okay. If you want to store 100 value, how many variables we require? 100 variables. Okay. If I want to create a program to store 100 values, to add 100 data, so I need 100 variables. Okay. So in order to store one data, one variable is sufficient. In order to store 100 data, I want to create 100 variables. So that is somewhat cumbersome or complex. In order to overcome that difficulty, what we are using? We are using an array. So where array is a collection of homogeneous elements which is referred by its index value. It is a collection of or set of homogeneous element which is of the same type. See, the array is saying it is taking the collection of elements. Collection of elements in the sense? Collection of elements in the sense. So, 100 elements it can take at once. No problem. Okay, for a single variable, it can take 100 elements at a time. But it should be of the same type. It won't take the data of different type. Okay, so that is called an array. Again, it is one of the very important question. What is array? Array is a collection of similar types of elements of the same type. Similar means in place of similar, you can replace a homogeneous word also. Okay, both are correct. Okay, so array is a collection of similar elements which is of the same type. If we are taking 100 elements, then all the 100 elements should be integer only. It should not be like that. The 50 elements will be integer, 50 elements will be float. It won't allow like that. Okay. So whatever the elements we are considering, that all the elements should be of same type. If we are collecting 100 elements, all should be either integer, otherwise all should be float, or all should be character. Okay. So that is called an array. So next we have the types of array. So before going to types of array, so here the arrays will be referred as an index value. It is referred as a number which is called an index value, and those index numbers will be referred using a subscript. This square bracket is called subscript in array. Okay, subscript or index. So here arrays will be provide the contiguous memory location. What do you mean by contiguous memory location? Contiguous means one after the other in a sequence. Okay. Suppose if the first element is stored in 100 location. Okay. Just imagine that the memory address of the first element is 100. This is the memory address. If the memory address of the first location is 100, then it won't go for 102 for the second location. It take the next address itself, 101. Then it go for 102. Then 103, 104 like this. So contiguous. Contiguous means next. Whatever the locations will be there. So orderly it will take all the locations. Okay. So that is here array. So and each address will be the size of the array will be represented here, and each address will be expressed in a form of a subscript or index value. Okay, so in this index value, so this index value will be start from 0 to n minus 1. Okay, the index value will be start from 0 to n minus 1. So that is first location the address will be of 0 and second location will be of 1. Like that, suppose if you are storing 5 elements, then it is taking 0 to 4. Got it? Suppose if it is taking the elements, then that is from 5 elements, it takes the address from 0 to 4. That is in the first 0th location, the first element is stored, and in first location, second, and in second location, third element is stored. Third location, then fourth location, likewise. Okay, so if we are storing 5 elements, then 0 to 4, n minus 1 means what? If n number of n is 5. So here, if n is 5, then the index value will be range from 0 to n minus 1. That is here 0 to 4. N is 5. N minus 1 means 5 minus 1. It is nothing but 4. Okay, 0 to 4. Likewise, if you want to store 100 elements, the index value will be from 0 to 99. If you want to store 50 elements, then the index value will be from 0 to 49. Understanding? So that is one pre-location name we are going to be taken in order to store that, because it is starting from 0. Okay. So here let us come to the types of arrays. Okay. So here we have around 3 types of arrays. The arrays will be differentiated into 3 types. So that is one-dimensional array, two-dimensional array, and a multi-dimensional array. What is one-dimensional array? One-dimensional array, the definition, whatever it is there for array, it remains the same thing. Only the thing is, so here one subscript or one index value will be added. That's it. Okay. So one-dimensional array is a type of array, so which takes the collection of homogeneous elements which is of the same type, and it has only a single subscript or single index value. That is called one-dimensional array. So how we are going to declare the one-dimensional array? So here the array will be declared as data type, array name, and the subscript. So in this index value, within this we are going to define what is the size of this. Okay. For example, if I want to store 100 elements, then data type. Suppose if I want to store integer elements, then the data type is int array name. I'll take any array name. Just I'm taking A is my array name. Okay. So then subscript. So if I want to store 10 elements, semicolon. Okay. So this is the general syntax for the declaration of a one-dimensional array. So that is data type, array name, and the size. The size indicates that how many values we can store. So here we can store around 10 elements, not more than that. Okay. If I want to increase this, so I have to change the size of this subscript itself. So where this size will be range from 0 to n minus 9. That is, it will be allocated something like this. E of 0 will be given to first location. Okay, so I'll write here E of 0. See, E of 0 will be allocated to the first location, then E of 1, second location, E of 2, E of 3, E of 4, E of 5, so on till E of 9. So like this, the index value will be given. Okay, so this is the general syntax of a one-dimensional array. One-dimensional array is a collection of similar elements of the same type with one subscript. Just you need to add only one subscript or one index value. So just we have only one index value. So that is called the one-dimensional array. So next we have two-dimensional array. So two-dimensional array, here also the same thing. It is a collection of homogeneous set of elements of the same type which consist of two subscript. So here two-dimensional means here will come across two subscript. See, two subscript. Okay. So where the size of this subscript, this array is also called as matrix array. All of you know the matrix, no? Yes. Because in 7th, from 5th itself we are going to solve the matrix problems and all. Or else in 7th, we have a 7 7th or 10th we have this matrix problem. So matrix is nothing but a set of elements in a combination of rows and columns. Okay, set of elements which is of a combination of rows and columns is nothing but a matrix. So here this two-dimensional array is also called as a matrix array. Okay, why we are saying that it is matrix? Because the first subscript indicates a row size and second subscript will be indicated as column size. Here the data will be stored in row and column format, same as your matrix format. Okay, hence so this two-dimensional array are referred as the matrix array. In examination sometimes it is asked what is the another name of two-dimensional array. So other time you have to write it is a matrix array. Okay, so here this matrix array consists of the elements combination of homogeneous set of elements which will be arranged in a matrix column. So which consists of two subscript. Okay, the size of the array will be defined as row and the column. Suppose if I am giving, so here also same type of elements. Suppose if I am giving int year of 5 and 10. What it means? Int year of 5 and 10. It means so 5 rows and 10 columns location will be allocated to store our data. So totally how many locations we can allocate? How we are going to find the number of data here in case of matrix? Rows into columns will give the total number of data. Okay, so that is 5 into 10. What is 5 into 10? It is 50. Around 50 data at a time we can store in this array. Understood? So this two-dimensional array is a matrix array. So where it is providing us to store the data in a matrix format, that is in a row and a column format. So here whatever the size we are giving for row and column, so that size will be accommodated and that location, that number of locations will be allocated. So here the order of the matrix indicate that the size of the data which will going to be stored in our array. So next we have multi-dimensional array. So multi-dimensional array is a type of array which consists of multiple subscript. See, in one dimensional it is a homogeneous collection of elements of the same type which consists of a single subscript. Okay, in one dimensional we have only one subscript. In two dimensional we have two subscript. Okay, so whereas in case of multi-dimensional we have multiple subscript. But in our software field we are not using much this multiple dimensional array because it is somewhat the complexity will get arise. Okay, so two dimensional means x and y will be there. That's it. Okay, dimensions only x axis and y axis will be there. It can be easily handled. But in case of multi-dimensional, it may be going x, y, and z beyond that also. Okay, so that is somewhat critical to access. In order to work on that difficulty, so this multi-dimensional array will be restricted and it is not using anywhere. Okay, only the experts, one who is good in this technology, only those people can be using this multi-dimensional array. So in examination it will ask, what is array? What are the different types of array? Explain for 3 marks. Okay, so one-dimensional array means it is a type of array which is consists of a collection of homogeneous element of the same type and consists of one subscript. This you should write. Okay, so consists of a single subscript. So in case of two-dimensional array, it is a collection of homogeneous set of elements of the same type with the two subscript. Okay, in case of multi-dimensional array, it is a collection of a homogeneous set of elements with multiple subscript. That's it. Okay, so here this is about the different types of array. So here in today's class we studied about what is the non-primitive data structure. Again we revised what is a linear and the non-linear data structure, and in brief we studied what are the different operations will be performed on non-primitive data structure, that is in a particularly linear data structure we are considering. So that is traversal operation, insertion operation, deletion operation, searching, sorting, merging. So this we have studied, and we studied about what is an array and what are the different types of array, how the memory will be allocated in an array. So in next class we are going to study about what is the one-dimensional array, how we are declaring that, what is the memory location, how we are going to calculate the memory of the one-dimensional array, and the algorithms related to the one-dimensional array.